This is a sphere S. There are P points on S. N is the normal vector of point P. T is the tangent vector of point P. N is a non-normal vector of point P. It is not perpendicular to the tangent plane of point P, but it is always perpendicular to T. Let the plane determined by T and N be pi. The intersection of pi and S is a circle. This circle is a great circle. We use C1 to represent. Let the plane determined by T and N be gamma. The intersection of gamma and S is a circle. This circle is a small circle. We use C2 to represent. We define. The curvature of C2 at P is non-normal curvature. It is represented by KNN. We all know that. The normal curvature Kn at T direction is the curvature of C1. So what is the relationship between Kn and KNN? Let the angle between NN and N be beta. So obviously, the angle between the planes of C1 and C2 is also beta. If the radius of C1 is capital R, the radius of C2 is lowercase r. So A equals cos beta. So Kn equals Kn cos beta. So if Kn remains unchanged, when beta approaches pi, 2, Knn tends to infinity. When beta approaches 0, Knn tends towards Kn. My first question. For general surfaces, is this conclusion also valid? I think this conclusion is also valid. The second question. Because when beta equals 0, the curvature of C1 is equal to Knn. So C1 is a spherical straight line. C1 is not bent. And it's just that the sphere is bent. Same as this. C2, small circle, is also a spherical straight line. C2 is not bent either. And it's just that the sphere is bent. Because the curvature of C2 is equal to Knn. Is that right? The third question. For general surfaces. At a given point, are the directions of maximum and minimum Knn perpendicular? Fourth question. Is there non-normal Gaussian curvature? The fifth question. Is the principal direction of Kn consistent with that of Kn? The direction of the maximum and minimum Knn is the principal direction.